Hi everyone, welcome back to the channel. And today we solve Leetcode daily challenge, problem number 23, merge k-sorted lists. So the problem is pretty straightforward. We will be given n sorted linked list. For example, this is a linked list in its own, and this will be a linked list, this will be a linked list. And we have to basically merge all these linked list into a single linked list. Okay. There can be multiple ways to solve this problem. You can use divide and conquer, you can use priority heap, or I think there will be around 8 to 10 ways in which you can solve the problem. For example, you can have, pointer at each of the linked list, and then you can, just compare all the values and merge it. So there are n ways to solve this problem. But today we are going to solve it using divide and conquer method, or simple, like, if I would say, like, we're going to simply use uh, a kind of a merge sort implementation. Okay, so what I'm doing is I will divide whatever number of linked lists will have into the elementary forms. In elementary by elementary forms, I mean, I'll divide this list until I have a single linked list as my leaf node, you can say. Exactly what we do at merge sort, right? And then we will merge both those, like first two linked lists, then the next two, then the next two, and then we'll perform the same operation, so on. Okay. So yeah, that's it's gonna be like that only. So we're gonna use recursive method and sort of a more sort implementation to solve this problem. Let's move to the solution and explain you what exactly we will be doing. Okay. So first thing first, I want to check few base conditions. For example, if if there is nothing in the lists, right? Then I want to return unknown. There is one more base condition. Let's say if length of lists is equals to 1. In that case, I just simply want to return the first element. And we need not to sort this because we already know that all individual linked lists are already sorted, right? Okay, next thing, I wanted to use merge sort implementation, right? So we have to divide this list in half at each step. So to figure out the mid, I'll use a variable called mid, and we will divide, like we'll do the floor division for all the elements we have in current list. And to divide it further, like in each step, we will have two subparts, right? Left part and the right part. So I'm going to recursively call merge k lists on first half till mid minus one. Basically, the last index is not didn't got included, and in the right subpart from from lists from mid to end. Okay, so we are done. Like we have divided the list in half at each step, right? So what text? Like as soon as we get single linked list at each step, we need to merge them, right? And for that, I would need a helper function. Let's name it merge, right? So I'm using self because this is how OOP concept work in Python. So we will expect two values in it, L1 and L2. Basically, two linked lists we will be using. And let me just call this left and right. Okay. Now, what we have to do in this merge is basically check if the element of L1 is smaller than L2, then I want to, start my linked list with L1's element. Otherwise, we'll pick L2 element. Simple comparison and adding to the current linked list. But before that, we will have to prepare a local linked list, which we will return at the end. And if you see over here, like as soon as we create an instance of a linked list, the first node or the first element in the linked list will have a zero value by default, right? So what we'll do is we will define a new linked list using list nodes, and we need not to pass anything because they have already used default parameters for this, right? And I also need a pointer to point at the current head of the linked list. Let's say for now it is pointing to the first node, okay? And at the end, when we'll have to return it, what we'll have to do, we'll have to return the from the second element because first one is zero, and we don't want to return from this point onwards. So this is it. Now what next? We will simply write a while loop while L1 and L2, like until we have any element in L1 and L2 both. We will do the comparison if L1 dot value is less than L2 dot value. Current dot next, sorry, current dot next will be equal to L1, and we will increment the L1 pointer. Else, we will simply do the same for L2. L2. Okay. Next, but like there is one more condition which we'll have to keep in mind. Let's say if L1 or L2, like any element in L1 or L2, remained unattended. For example, elements in L1 got over, but there were some elements in L2. So you'll have to consider those as well. So what we'll do, we'll just simply write current dot next will point to whatever element is left among L1 or L2. So I think, yeah, that is it. This was the complete solution. Let's check out the test cases. Okay, generative object. Okay, with a number is not valid for is not valid value for expected return type. Mhm. Must have missed something. What is it? Okay, self dot merge. This should have been, and I think everything looks fine. Okay, so we're just giving output as 6. The last element, it should have been the other way around. Oh, yeah. So one thing which we missed is we do have to increment the current pointer, right? So current will become current dot next. I think this will do the job now. Yeah. So the test cases got clear. Let's submit for further evaluation. Awesome. So the solution got accepted, and I would say we have performed decent. Like we performed well because if you see the distribution, most of the solution was in the same on the same lines. So yeah. Thanks, guys, for watching out the video and stay tuned for the upcoming ones. Don't forget to subscribe to the channel. Thank you.